Good afternoon. So I am Ramesh. I am going to explain about the topic of Boolean minimization using K-map. So we all know that there is various methods are available to simplify the Boolean expression. So one is traditional method, and another one is Karnaugh Map, and third one is Quine-Meglowski method. So we all know in traditional method we need to remember all the Boolean postulates and theorems. So it is very difficult to remember. So in order to avoid that, we are going with some other method which is called as Karnaugh Map. So in Karnaugh's map, this Karnaugh map is determined by a number of input variables. So we all know in Karnaugh map is a graphical method of simplifying Boolean expression. So in Karnaugh map there is various number of cells are present. So it is determined by the number of input variables. Actually it is mathematically expressed by 2 raised to the power of n. Okay, suppose if it is having 2 number of variables, the Karnaugh map will have 4 cells. So here each and every cells represents the minterms of the Boolean expression. Okay, so for example, see here there is 2 inputs. So here we require K-map with 4 cells. So we know that 2 power 2 is equal to 4. Therefore we have 4 cells. Similarly, when we go for a 4 input logical expression, there will be 16 cells of K-map. See here, usually for 2 variable K-map, the number of input variables are 2. Therefore we require 4 cells. So we know in input A and B, so 0 A and B, therefore the combination will be 0 0 0 1 1 0 1 1. Okay, therefore if it is 0 0, the decimal equivalent is 0. If it is 0 1 1, 1 0 in the sense 2, 1 1 in the sense 3. Okay, so the equivalent minterms are M0, M1, M2, M3, which will be represented by A bar, B bar, A bar B, AB bar, AB. Okay. So in K-map there will be 4 cells. Each cell will represent 0, and another cell will represent 1, which means minterm 1. Another cell is minterm 2, and another cell is minterm 3. So likewise we are going to mention in the cells. So like this. See here. This row represents this row. These 2 row will belongs to variable A. This 2 column will belongs to variable B. Okay. If A equal to 0, B equal to 0, this cell will produce 0th minterm. Similarly, this A equal to 0, B equal to 1, this cell will provide a 1, first minterm. Similarly, when A equal to 1, B equal to 0, the cell provides minterm 2. Then A equal to 1, B equal to 1 provides minterm 3. So suppose if we want to simplify our Boolean expression, first of all we need to convert it into the standard SOP format. Then we have to represent it into the sum of minterms. Finally we will mark all those minterms into in this box. Okay, so that we can easily simplify it. Okay. For example, see here F equal to A bar B plus AB. So consider this. Okay, A bar B plus AB. So here there is a cell which will have A bar B. Which cell is A bar B? First row, second column. Similarly AB in the sense first, second row, second column. Therefore we have to mark those cells by 1 and 1. So these 2 minterms only present in the output function. Therefore we have to mark these 2 like this, 1 and 1. Okay. So remaining and all A bar, B bar and A, B bar is not available. Therefore we have to mark it as a 0. So only we are marking A bar B and A B as 1. Okay. So now we have to group these two. So we already we know that the adjacent cells are only one variables are changes in adjacent cells. When we move from either right side or left side or upper way or bottom way, in anyhow we are moving, in the sense there will be only one variable or changes. See here, this is a bar b, this minterm. What about this one, a b? So a bar b and a b. So in this only a only changes. What about b? B is common. Therefore by using this kind of things, we are going to simplify it. Okay, so here we are mapping a bar b and a b. Therefore we are grouping like this. Okay, we need to group like this, right? Then how the output function will be written, in the sense, see here, f equal to b. Why? Because so here first row as well as the second row both are grouped. Therefore this row belongs to a bar, this row belongs to a. Therefore a bar and a will get cancelled. Okay, only this column alone mapped, right? Therefore this column belongs to b variable. Therefore output function f equal to b. So when we are simplifying f equal to a bar b plus ab, we will be getting answer as f equal to b. Okay, so with the help of normal logical Boolean expressions, so here b is take it out commonly outside. If you are taking b commonly outside, what will be remaining now? A plus a bar. You know a plus a bar equal to 1. Therefore 1 dot b equal to b. The final answer is b, f equal to b. So it is a very simple function, so that easily we can using Boolean expressions, I mean Boolean laws and theorems, we can easily simplify it. When we go for higher variable, it is difficult to realize, I mean difficult to solve. Okay, so this is the second example. F equal to a of b equal to summation over m of 2, 0, 3. So here minterm 2 and minterm 3 and minterm zeros are present. So we need to simplify with the help of K-map. See here minterm 2 is there. Therefore we have to map that minterm as 1. Minterm 3 is there. Therefore we have to mark it as 1. Minterm 0 is there. Therefore we have to mark it as 1. Okay, so now we are going to form a group. So when we are going with this minterm 0 and minterm 2, only one variables are changes. Therefore we are grouping as a pair. Similarly, when we are moving from 2 to 3, minterm 2 to 3, only one variables are changes. Therefore we are going with this pair. Okay, so here all the ones are mapped. Okay, therefore the final result will be f of a comma b equal to b bar plus a. This a represents this yellow color pair value, and b bar represents blue color pair value. Similarly, for 3 variables, see here there is a 3 variable. Therefore the total cells required is 2 raised to the power of n. Therefore 2 to raised to the power of 3 equal to 8. Therefore we will have 8 cells. Okay, from 0 to 7, which means minterm 0, minterm 1, minterm 2, minterm 3, 4, 5, 6, 7. So totally we have 8 cells. Okay, so the structure will be like this. So you see here 0, 1, 2, then 3. So when we move from minterm 1 to minterm 3, see here minterm 1 to minterm 3, minterm 1 represents a bar b bar c, minterm 3 is a bar b c. Okay, so when we are moving from minterm 1 to 3, only one variable changes. When we are moving from 1 to 2, 2 variable will be changes. Therefore it is not allowed. That is why we are rearranging 0, 1, then 3 followed by 2. Similarly in second row also 4, 5, 7 and 6. Why? Because when we move from 5 to 7, only one variables are changes. Similarly, when we move from 7 to 6, only one variables are changes. Similarly, when we move from 3 to 7 also, only one variable are changes. See here 3 is equal to a bar bc. What about 7? A bc. So a bar bc, a bc. So here only a only changes. What about bc? Bc are common. Okay, so this is the basic arrangements of 3 variable Karnaugh map. Okay, so this is a f of a comma b comma c equal to a bar b bar c bar plus a bar bc plus a bar b c bar. Okay, so we are going to simplify this function with the help of Karnaugh map. So see here, A bar, B bar, C bar, in the sense it is a min term 0. That is why I am putting min term 0 as 1. Then A bar, B, C. You know what is A bar in the sense 0. What about B, C? 1, 1, which means min term 3. That is why min term 3 is represented by 1. Then A bar, B, C bar, which means 0, 1, 0. Therefore, it is equivalent to decimal number 2, which means min term 2. Therefore, min term 2 will be put as 1. Okay. So how do you map in the sense? When we move from 2 to 3, only one variables are changes. Therefore, we are mapping, which is represented by one blue color. Similarly, min term 2 is 1, min term 0 is 1. Okay. So only min term 0 is not mapped. You know, the first column and last columns are adjacent. Adjacent in the sense only one variables are changes when we move from the adjacent cells. One cell to another cell, only one variables are changes. Therefore, 0th min term and 2nd min term are adjacent. Therefore, we have to map it as 0 and 2 with the help of yellow color. I am pairing this. Okay. So the answer will be for yellow color. So first column and last column, it is belongs to first row. Therefore, A bar. Okay, A bar. Then what about first column and second column value? 0, 0, then 1, 0. Okay, 0, 0, then 1, 0. Therefore, here only second variable is common, which means C bar is common. What about B? B is changes. Therefore, we are omitting that. Okay, the answer is in the row value is A bar and the column value is C bar. A bar, C bar. Plus, what about this blue color? This blue color also belongs to first row. So first row belongs to A bar. What about a column? So it is mapping two columns. One is third column and another one is fourth column. Okay. So here B is common. What about C? C is different. Therefore, we are omitting the C variable. We will be having only B. Therefore, A bar B. So another example. Simplify the Boolean expression using K-map for the function f of a, b, c equal to summation of min term of 0, 3, 7, 6. Okay. So in 3 variable Karnaugh map. So here 0, 3, 7, 6. Okay. So min term 0, min term 3, min term 7, min term 6. It is only present. Therefore, when we go for the 3 variable Karnaugh map. So we are going to mark one as min term 0, min term 3, min term 7 and min term 6. What about remaining min terms? It is not in the list. Therefore, we have to mark it as a 0. Okay. Now, so how do you group? So just take 3, 7. Okay. When you are 3 and 7 are adjacent, therefore we have to pairitize. We have to make a pair, 3 and 7. So which one is left out? Only 6 and 0. So how do you map 6? So 6 is mapped with 7 also, right? Therefore 6 and 7 are paired. Sir, you may ask one question. Sir, already 7 is covered with this pair, sir. We are mapping again and again. Yes. So if you are mapping 6 alone, then it will produce 3 variable. I mean 3 literal function. Okay, but when you are mapping with when you are grouping with 7, it will produce only 2 literal function. Okay, so that is why we are preferring, we are mapping 6 and 7. Okay, what about min term 0? So min term is 0. Min term 0 is adjacent with either 1 or 4 or 2. Clear? Either 4 or 2 or 1. So these 3 cells only adjacent to the min term 0, but min term 2, min term 1 and min term 4 are 0. It is not in the list. Therefore, there is no other way. Therefore, we are mapping a min term 0 as singular. Okay, singly we have to map. Right. But now, what will be the answer? See, f of a, b. It is output function f of a, b, c equal to, the green color represents a single map. Okay, therefore which is belongs to first row, first column, which means A bar. What about first column? B bar, C bar. Therefore we have to mention it as A bar, B bar, C bar plus. Okay, then this yellow color which is belongs to both rows. Okay, if both the rows, in the sense A bar and A both are get cancelled. A bar A, you know, A bar plus A equal to 1. So no need to worry about this. Therefore we have to omit this. Then with this yellow color belongs to third column alone. Therefore BC alone will come. Similarly plus this blue color pair represents which belongs to second row. Second row belongs to A. Then it is belongs to column 3 and column 4. So this column 3 and column 4 belongs to BC and BC bar, in which B is common and C bar is different. Therefore we can omit C and C bar. We have to take only B value. Okay. So therefore AB. So this is the output for 3 variable Karnaugh map. So let's move to 4 variable map. See, the number of input variables here are 4. Therefore the total number of cells required is 16, which means 2 raised to the power n is equal to 2 raised to the power 4, which is equivalent to 16. So there will be a K map which will have 16 cells. Okay, 16 cells. Each cell will provide one minterm. Okay, see, this is minterm 0, minterm 1, minterm 3 and minterm 2. As I informed earlier, when we are moving from 1 to 3, only one variable are different. Similarly, when we are moving from 3 to 2, only one variables are different. Okay, not 1 to 2, 2 to 3. Clear? That is why we are moving like this, right? 1 to 3 is only one variables are different. Okay. Similarly, 4, 5, 7 and 6. Then 8, 9, 10 and 11. Okay, so what we are following in the column wise, that is also followed in row wise. Okay, 4, 5, 6 and 7. In the last row will have belongs to 8, 9, 10, 11, then 12, 13, 14, 15. So it is a basic structure of 4 variable Karnaugh map. Okay, so let's take one example. So this is a function f of a comma b comma c comma d equal to a bar b bar c bar d bar plus a bar b bar c d bar plus a b bar c bar d bar plus a b bar c d bar plus a bar b c d plus a b c bar d. Okay, so here we are going to simplify this function with the help of K map. Okay, so a bar b bar c bar d bar, so all are 0, which means that 0th minterm is present. Then a bar b bar c d bar, which means 0 0 1 0, so minterm 2 is present, so we have to put minterm 2 is 1. Similarly, a b bar c bar d bar, which means 1 followed by 3 0, 1 followed by 3 0, in the sense minterm 8. Where is 8? Here. Similarly, a b bar c d bar, which means 1 0 1 0, which belongs to 10, so minterm 10 also present. Then a bar b c d, which means 0 1 1 1 3. Okay, 0 1 1 in the sense 7, minterm 7. Then a b c bar d, which means 1 1 0 1, so 12 plus 1 13, 13 is present. What about remaining minterms? All not available, therefore we have to mark it as a 0. Minterm 1 3 4 5 6 12 14 15 9 11, so these are all 0 because it is not available. Okay, now so we are going to map. How do you map? So see, when you are looking this Karnaugh map, so all the 4 corners are 1, which means that all the 4 corners are adjacent. Okay, so therefore we are going to map this as a 1 quad. Okay, so group of 4 minterms are called as quad. Therefore this minterm 2, minterm 10, minterm 8, minterm 0, so these 4 are adjacent. Therefore we are mapping it as a 4 group of minterms, which means quad. Okay, right, so all the 4 corners are mapped. Then minterm 7 and minterm 13 only not mapped. Now we are going to map, so there is no adjacent cells are as 1 for minterm 7 as well as minterm 13. So only minterm 7 and minterm 13 alone 1. What about its adjacent? All 0. Therefore we are mapping it as a single. Okay, therefore the final output will be, so for all the 4 corners, which means first row and last row. So first row belongs to a bar b bar, second row belongs to a b bar. Okay, 0 0 0 1 1 1 1 0 row. Here 0 0 0 1 1 1 1 0 column. Okay, clear? Right. Now, So all the four corners are mapped now. Therefore, first row and last row, which belongs to A bar, B bar and A B bar, in which A bar is A is different, B is common, right? Therefore, I am taking B bar alone. What about first column and second column? So here C bar and C, D bar and D bar. D bar and D bar is common. Therefore, we have to take it as a D bar. So B bar, D bar for this green color quad. So group of 4 minterm is called as what? Quad plus. So you know, what about this yellow color? Yellow color is no other, only singly it is mapped. Therefore, this is belongs to second row and third column, A bar B C D, A bar B C D plus. What about this blue? It is also blue and single. Clear? Therefore, it is belongs to third row, second column. Therefore, A B C bar D, A B C bar D. So this is the final answer for this K-map. So when you are simplifying with the help of normal Boolean laws and theorems, it is very difficult to solve this. Okay, but in order to K-map, it is easy to solve. Then another one example. So here simplify the Boolean expression using Karnaugh map. So f of A, B, C, D, which means there is a 4 inputs summation over minterm of 0, 2, 4, 6, 12, 14, 15, 8 and 10. Clear? Here, so totally 3 plus 3 plus 3. So totally 9 minterms are present out of 16 minterms. Clear? So the corresponding minterms are marked as 1. So now, I informed you earlier, first column and last column are adjacent. Similarly, first row and last column are adjacent. So here, first column all are 1. Here, second column all are 1. Therefore, we are mapping like this. So it is called as octet. Which means what? Octet. You know, group of 8. One is called as octet. Therefore, here octet pair is there. Octet pair. Then only 15 alone not mapped. So here if 13 is 1, so this third row belongs to one more quad, but 13 is 0, so no other way, only we are going to map with what? 14 and 15. Okay, yes. Now we are going to write the equation for each and every pair. See, for this octet belongs to all the 4 rows, which means A bar, B bar. This is A, B, both are get cancelled. Similarly, A bar, B, A, B bar, here also both are will get cancelled. So when the pair is covering all the 4 rows, row variable will not come. So that is why in first, in green colors, no, in green color, there is no A and B. See, there is no and B. Only it will have only column variable. In column also, it mapping 2 columns. Therefore, first column and the second column it covers. Therefore, C bar, D bar, C, D bar. First column belongs to C bar, D bar and C, D bar. Therefore, in which D bar only common. What about C? C is different. C and C bar. Therefore, we are omitting C and C bar. Only we are taking D bar. Common variable alone we can take. Okay, D bar plus. What about this pair? So, pair in the sense, so this pair belongs to third row. So third row is AB. Okay. Then it is covering 2 columns. One is third and another one is 4. Okay. In which C is common. What about D? D is different for both columns. Right. Therefore, I am taking only C alone. So here, see this green color and blue color. So these are all called as prime implicant. Okay. So the name of this mapping is called as what? Prime implicant. Okay, so each and every pair, every group is called as what? Implicant. Prime implicant. Okay. So in Boolean expression, one more thing is there which is called as a don't care, which belongs to either we can take it as a 1 or we can take it as a 0. So here we are going to discuss K-map with the don't care condition. So see here, f of A, B, C, D, in which the minterms are present, which is called as 3, 7, 9 and 11, plus summation over D in the sense don't care of 1, 5, 12 and 14. Clear? So how do we simplify with the help of Karnaugh map for this minterm as well as don't care functions? So for this, so the minterms, the actual minterm is represented by 1 and 1, but don't care are represented by x. Okay, x represents don't care. So now, so there is a minterm 3, 7, 9, 11. So these 4 are present, therefore 3, 7, 9 and 11. So it is only represented by 1 and 1. Okay, what about the remaining thing? So don't care will be represented by x, no? X by for the minterm 1, 5, 12 and 14. So that minterm 1, minterm 5, minterm 12, minterm 14. So the mapping is like this. I mean minterm and don't care enter into the map is K map is like this. Okay, so now we are going to group it. So if required, we will take x as we will consider x as 1. Suppose see here 3 and 7 are adjacent, but adjacent of these two are 1 and 5. So this 1 and 5 also what? X and x. X and x represents what? We can take x as 1 or 0. So here, so I am considering x, both x's are 1. Therefore, I am covering with the help of one quad. Okay, one quad. And so see here, first row and last column. Okay, first row and last row. 1 and 3. See, look, 1 and 3. So 3 is 1. What about 1? 1 is x. What about last row? 9 and 11. Both are 1. So if I am mapping with the help of this quad, x will be considered as 1. Yes. So therefore we will have a 2 quad group of combinations. Okay. So the final output will be like this. So this blue color belongs to A bar D, and green color value will be B bar D. So when you are using Karnaugh Map, okay, it is very easy and error free. We can get a result. Okay, so these are all some merits I am listed here. So when you are using K map simplification technique, it is very simpler, and also it is less error prone compared to the method of solving the logical expressions using Boolean laws. And also it will help to prevent to remember the each and every Boolean algebraic functions. Okay, this is another merit, and it involves fewer steps than the algebraic minimization technique to arrive a simplified expression. So it is very easy to solve. And also K-map simplification technique always results in minimum expression if carried out properly. So it always providing the minimum number of expressions to carry it out in the result. So what is the problem in K-map? As the number of variables increases, K-map process is somewhat complicated. Okay, therefore, so the minimum logical expressions arrived by using K-map simplification process may or may not be unique depending on the choices made while forming the groups, because sometimes I am using 0 and 1 as one pair. In someone will use 1 and 2 will be as a pair, and 0 and 4 will be as a pair. Okay, so it is all because of the user. Okay, user can form a group based on their choices. Therefore, each and everyone will have a different answer for the same problem. Okay, so that is another problem of Karnaugh Map. Okay, so it will be eliminated or reduced with the help of Quine-Miglowski method. So we will discuss Quine-Miglowski method in another session. Thank you.